Today I shall discuss the techniques of quadratic equation. A quadratic equation which involves a single variable x of the type ax square plus bx plus c equal to g, where a, b, c are real and a is a non-vanishing term, that is a cannot be 0. If a becomes 0, then if a becomes 0, then the equation 1 reduces to bx plus c equal to 0, which is a linear equation, which is not a quadratic equation. An equation will be quadratic if the power of x or degree of x, degree of the equation is 2, then it is quadratic. Since the equation reduces to this type and it involves x power 1, this term consists of the highest power of x is 1. So this equation is a linear equation. If the highest power in an equation becomes 2, then it is quadratic. If the highest power of x becomes 3, then it is cubic equation. So in this way we can generalize an equation of n degree. If the highest power of an equation has n, so it is an n degree equation. Anyway, so case 1 actually represents the linearity, and case 2, if a is non-vanishing but b is equal to 0 and c is any real number, it may be 0 or may not be 0, then equation 1 reduces to ax square plus c equal to 0, and which is a quadratic equation because the highest power of x is 2. This is a quadratic equation, and this equation will have two roots or two solutions. If the equation, now case 3, if a non-zero and b non-zero but c, the constant term c is 0, then equation 1 reduces to ax square plus bx equal to 0, and this is again a quadratic equation because the highest power of x is 2. And in this equation it is clear that x equal to 0 must be a solution or roots of this equation. Now why x equal to 0 is a solution of this equation we will discuss later. Whenever we solve the equation, quadratic equation, then we show that the roots